good afternoon, everybody. I hope today is going well for you. We're going to jump right in. You had an introduction to Chapter 10 yesterday, an exploration that we did. Today we formally start Chapter 10, and today's warm-up is a review of ideas from the recent past. Let's see how we did. Stay on your toes. Equity bars are in effect. What is the length of the mid-segment? I got student number 1, 20, 17, and 6. Student number 1. Student number 20. Student number 17. Student number 6. Okay, then I got student number 2, 21, and 18. Student number 2. Student number 21. Student number 18. The correct answer is, there's actually two answers, 104 or 136 units. If you got one of the answers, then you can go ahead and mark it correct, although technically you're supposed to get both answers. So, as I walked around, I saw a particular type of struggle happening. I don't think this struggle was geometry, I think the struggle was algebra. But let's make sure we got the geometry down. Could I have a volunteer who feels confident about what they set up? Tell us how you started. Alicia?
I did, first I multiplied the 16x minus 8 by 2. And then
16x minus 8, you multiplied that times 2. Okay?
And then I got 32x minus 16
Okay.
equals 110 plus 2x squared.
Okay. Very good. Anyone set up something different? Maria?
110 plus 2x squared divided by 2 is equal to 16x minus 8.
It's the same thing. But either way you get the same results. These are equivalent equations. So now, let's go ahead and simplify. I'll start with Maria's just because I happen to write hers underneath. So it's 110 divided by 2 and 2x divided by 2. We end up with 55 plus x squared equals 16x minus 8. And then the world crumbled down on you because you didn't remember what to do next. What type of equation is this? This is a quadratic. Last year, you learned a whole bunch of different methods to solve a quadratic, and you're going to see in a moment how simple this really is. You'll also see how Maria's setup is a hair easier than the first one, but either way, you get the same result. To solve a quadratic, you need the whole quadratic on one side. So we just need to get everything on one side. Doesn't really matter how you do it, but we need x squared. It's already here on the left. We need the 16x to come over, so that's going to be negative 16x. And we need the negative 8 to come over, and it's going to turn positive, and we get 63 equals 0. So what are your options at this point with a quadratic equation? Brandon? You can factor it. In fact, pay attention, it factors quite easily. What are the two factors? You're on a roll, Brandon. Keep it going.
7 and 9.
Hold up.
Wait. Are you asking for anything in the book?
In the parentheses, yes.
X minus 7 and
X minus 7 times x minus 9 is how it factors. To solve the quadratic equation, you set each factor equal to 0. So you set x minus 7 equals 0, x minus 9 equals 0, and you solve, and you get two values for x, 7 and 9. Plug them both in right here, and you get two different answers, 104 and 136. Zabari and then Davis. Beautiful. Did it work? That's why it's there. Davis?
How did you get 79 again?
Two numbers that multiply to 63 and add to negative 16. Negative 7 times negative 9 is positive 63. Negative 7 plus negative 9 is negative 16.
I'd like to ask if you're asking for like a similar question, you only give $1
I'll have to think about that. I certainly don't, I'm not a huge fan of trying to trick you guys. You know, I think demonstrating understanding is demonstrating understanding. But I would think about it. If there was something that was unusual, I would hopefully warn you. Okay? So Catalina, you took a different approach when you got to here. What did you do?
I didn't see like the connection that you could make, and I just started doing guess and check.
Which is totally appropriate. But what issue did you end up with because you did that?
I only got one answer because I got it.
Right, because you were looking for one answer, you got it, so you're done, right? So that's the maybe one tiny drawback to what you did, but other than that, great approach. She did guess and check. She just kept trying numbers and found the one that worked. Okay? Any comments, questions, any concerns, any observations? Good. So today, as I already indicated, we are entering chapter 10, which is all about circles. I already gave you your cheat sheet, which you should have out on your desk. You're going to need it. Remember, the cheat sheet is a good news, bad news. It requires effort. The cheat sheet requires effort. So I've put blanks on the cheat sheet for you to fill in as you work. You can either fill them in as we work in class. You can fill them in as you work at home. It's really up to you to figure out the best way to utilize it. But all of the blanks should be filled in as you go along. So our goals today are quite a few. We're going to be able to identify tangents, secants, and chords, and you already learned some of that yesterday. And we're going to learn how to use properties of tangents to solve some different types of problems. Got a lot of new vocabulary. You were introduced to two words yesterday, tangent and chord. We've got interior of a circle, exterior. We've got chord, secant, tangent, point of tangency, and common tangent. A lot going on today. Any comments or concerns before we really get into it? Okay, so here is a picture, and in it I've illustrated 5 different types of segments. So we're going to do a short activity. As a team, you are going to come up with informal definitions of each of these terms: chord, radius, diameter, tangent, and secant. Your goal is to be able to tell the class what distinguishes a secant, what makes it what it is. In other words, what makes a square and not a parallelogram? A square is a square because it has 4 right angles and 4 congruent sides. A parallelogram has 2 pairs of congruent sides, but it does not necessarily have right angles. So what are the distinguishing characteristics? What are the distinguishing characteristics? Okay? So you need to be able, and I'm going to call on teams when we're done. You as a team need to be able to tell me what a chord is. What makes a chord a chord? What makes a diameter a diameter? What makes a radius a radius? Let me give you one little hint. Do not tell me that a radius is half of a diameter. That's something you learned 3 or 4 years ago, and it is true, but that's not what really makes a radius a radius. So don't tell me that. Okay? So we're going to put 4 minutes on the clock, and you've got 4 minutes to, with your team, come up with a definition for each of these terms. Go.
Inside a circle or the angles all touch this side. That's a line that passes through the center.
Tangent is outside of your
Or it's not necessarily a square line that connects 2 points in a circle. And then the diameter, and then this means from one side of the circle to the opposite edge, so you go to one circle up, and then the radius is the distance from the center of the circle to anywhere on the edge. But the line and is perpendicular to diameter. Yeah. Is a line that connects 2 sides of the circle with no, but does not cross through the center of the circle.
When I call on your team, you're going to have to be able to articulate using math terminology. Doesn't have to be super formal, but you need to be able to articulate well. And make sure you know all the characteristics that make something what it is. Radius is the distance from the center of a circle to any edge of the circle. Just to clarify one thing from yesterday, that this point in the middle is called, it's just called the center. So the center of the circle. Let's see what we've come up with. So let's start with a chord. Let's start with Team A. Team A, how would you describe a chord?
A chord is a line segment in the interior of a circle that leads into S2.
Okay. Give me a thumbs up if you think she's covered it all, that their team covered it all. Okay, Dalton, you don't think they covered it all? Okay, what was your definition? Okay, she actually did cover all that. Okay, good, thanks for the thumbs up. Okay, yeah, I think you guys covered most of it. It's a segment on the interior, I love how she said on the interior of the circle. that goes from one point on the circle to another. Very good. Nicely done. Anyone have any details that feel like we missed? Chris? I'm not sure. What do you think? Okay, well, let's see what we come up with by the end. All right. Davis, you think we missed something?
It does not continue past the wait, no.
Okay, so just to clarify, the endpoints lie on the circle. Very good. You think that a diameter is also a chord. Okay, we'll get back to that. Let's go to radius. Team E, what did you guys say for radius? Fung, what did your team say for radius?
Radius is the distance from the center to any edges of the circle.
Very good. I'm very impressed. Most of the students that I've worked with so far weren't able to get that word out, and that was great. A radius is the distance from the center to the circle. Could have said it's a line segment from the center to the circle to any point on the circle. But yeah, it's the distance from the center to any point on the circle. Very good. What about a diameter? Team C, what did you say? Go ahead.
A straight distance, an 80, through the center of the circle to two edges of the circle.
Okay, two edges. Circle doesn't really have edges, but I think okay, 2 points on the circle. Good. Okay, anyone say it differently? That was pretty good.
Distance from one end of a circle to another end of the circle while passing through the center.
Okay, so one key characteristic is that the diameter passes through the circle. Passes through the center of the circle. And yes, the endpoints of the diameter are points on the circle.
When the 90 degree, it would have to be 90 degrees. When it has to have a 90-degree angle at one end. Because it's 90 degrees.
Oh, that's just indicating its relationship with the tangent line. Yeah, it didn't come out as well as it should have. That actually goes all the way to the tangent line. That goes all the way there. So sorry about that. Good. I mean, another way to say it is that a diameter is a chord that passes through the center. So Chris, does that answer your question? Or your point? Very good. What about a secant? What is a secant? Let's go with Team B. Team B, what's a secant?
It's similar to a chord, but it does not stop at the end of the circle.
Okay. Similar to a chord. Okay. What if we didn't know what a chord was? How would you describe it if you didn't know what a chord was?
It is a segment that passes through two edges of the circle and continues.
It's a secant is a line that passes through a circle.
That's pretty much it. Secant is a line that passes through the circle. But it passes through 2 points on the circle. Okay? And so let's try to get away from the word edge. There are no edges. Edges, it kind of implies a straight line. These are just all points. A circle is just a set of points, all the same distance from the center. Okay? I know we didn't cover that basic fact, but I guess I expected that you already kind of understood that. That a circle is just a set of points, all the same distance from a center point. So the secant is a line, and that was a key word, line. It's not a segment. It's a line that passes through 2 points of the circle. Good. Tangent we already covered yesterday. You should have gotten to know tangent pretty well. Does anyone have any comments, questions? Go ahead, Catalina, and then Ann. Catalina.
Does that kind of tangent relate to the tangent like that we use for the tangent, cosine, and sine?
It's a good question. Ann.
Will we ever have to solve a problem where the secant and tangent?
What do you think?
Yeah.
If you can envision it, then it's out there.
Right.
Okay? If you can envision something, then it exists. So clearly there's some scenario where that could happen. Brandon?
So wouldn't a diameter basically be 4 that
Thank you for repeating what I said a few minutes ago. That's exactly what I said. It's a chord passing through the center. Very good. All right, so we've laid the foundation. Now we can build from there. So, on our cheat sheet, if you'll find the first two theorems. Now, I'm pretty sure I said this yesterday, but I just want to reiterate that the publisher of your textbook uses a lot of numbers for these theorems. They don't matter. I took a little bit of time, because I wanted to, and found the appropriate names for the theorems, but they don't really matter. It's the ideas that matter. And luckily, the ideas, when you use them, start becoming part of who you are. So Tristan, you have to make sure that even though I've given you a cheat sheet, and it's just laid out for you almost perfectly, part of your job is to start absorbing, start utilizing the ideas so that they become part of who you are. That's the key. So, the tangent theorem. I want you to pay particular attention to the way that it's written. In a plane, a line is tangent to a circle if and only, and that's a typo, if and only if, that's not supposed to be there, the line is perpendicular to a radius of the circle at its endpoint on the circle. What does the if and only if tell us? Tells us something very important. Good, we got a bunch of people. Jada? Very good. Does anyone remember what it's called when it's written this way? Anne? Very good. Excellent job. This is a biconditional and it works in both directions. So if a line is a tangent, then it's perpendicular to a radius. If a line is perpendicular to a radius, then it's a tangent. So it works in both directions. So in essence, this is actually two theorems all wrapped up into one. Any questions about that? And we're going to be using this so much that it will be effortless for you. The second one is the tangent segments theorem. And it states that if you have two tangents of the same circle connecting at the same common point, then the two tangents are congruent. So in this diagram, it's written out for you here in words, but we can say that that is congruent to that. If this is tangent and this is tangent and they are both touching the same point, then they are congruent to each other. Does anyone have any questions about that? So we are going to use these ideas within our explorations today. Any questions? Okay, so we're going to come back to the theorems in a little while. We're going to do one more quick little activity to try and make sure we've developed a very good understanding of the different terms. I do not want you to attempt to draw this picture. That would be asking way too much. And I did toy with the idea of printing it out for you, but it's actually going to be unnecessary, and you'll see why in a few minutes. But what I'd like you to do with your team, yes, this is an example, but we're going to use it as a quick team activity. I would like you to tell me the best name, the most specific name for each of these objects, A through E. The best name. Remember that objects can have more than one name. For example, a dollar bill can be called money, and it can also be called a dollar. Which name is more specific? Dollar is more specific. It tells you more about what it is. So what is the best name? So I would like you to take, I think this is a 2-minute activity. I'll put 3 minutes on the clock. I would like you to come to a consensus with your team as to what the best names are for these different objects. Ready, go. Alright. So now let's come back as a whole group and see if we can come to consensus as to what the best names would be for each of these objects. Let's start with segment AC, and I've got team A. Alicia, what did your team conclude that was? A radius. So this team proposes that this is a radius. Everybody else, give me a thumbs up if you agree that the best name for that is a radius. Many of you do. Good. Put your thumbs down. I would agree that the best name for that is a radius. Very good. Part B, segment BD, and I have team B. Shelby, what did your team conclude that the best name was for that? I'm sorry? Chord. Your team proposes that the best name for this would be chord. Everybody else, give me a thumbs up if you agree that the best name is chord. Yeah, and I did, good, put your thumbs down. I did try to trip you up a little bit with B and C. In part C, that's line BD, and, well, interestingly, I've got team C. Kayla, what did your team conclude the best name would be for that? A secant. So you guys propose that this is a secant. Everybody else, give me a thumbs up if you think best name for that is secant. Good. A lot of you. All right, put your thumbs down. What about line AG? I've got team F. Where's team F? Sebastian, what did your team conclude was the best name for line AG? Tangent. So your team thinks it's a tangent. Anyone disagree? Anyone disagree that that's a tangent? Not only is it a tangent, but you're going to learn in a little while that that's actually called a common tangent because it is tangent to both circle C and circle H. So it's a tangent and it's another tangent. It's called a common tangent. We're going to explore that in a little while. Yes?
So the point
Yes. The name of the center point is the name of the circle. Very good. Thank you for bringing that up. All right, and what about line EF? I've got team E. Team E, Daniela, what did your team conclude the best name would be for that? Tangent. Very good. So this would also be a tangent. And you're going to see in a little while that that's also a common tangent. It's tangent to circle C right here, and it's tangent to circle H right there. That's a common tangent. This one's called an external common tangent, and this one's called an internal. Any questions on this terminology? I'm not sure. I'll have to look it up. Seems like there could be, because you could have a secant pass through one circle and then another. I don't know if they call it a common secant or not. Any other comments or questions?
So anything that shares something with a different circle is common something?
That's the question. I don't know. I know it's called a common tangent. I don't know if that applies to other words. Okay? Any other comments or questions? Okay. Example 2. Now let's explore the common tangents. And you are going to have to sketch these. Did I give compasses? Okay, so let me quickly get compasses out. And you're going to have to find some space. You do not need to draw these pictures large, but you need to try and so graph paper makes certain things a little bit easier. So, if everyone will take a moment to draw the diagram for part A, don't worry about part B yet. Draw the diagram for part A. And it doesn't need to be perfect, it doesn't need to be exact, but try to get the spirit of the diagram. A smaller circle, a space, and then another larger circle. Try to have that done. One of your peers in another group noticed that there are little holes in the circular part of the compass, and that could also be used to draw a circle. However, it was a little bit challenging.
Oh yeah. I did it.
Take about 30 more seconds to just get the diagram.
It's hard to I'd rather like draw my own.
All right. So now let's come back as a whole group for a moment, and then you're going to actually be on your own for another couple of minutes. Actually, another minute. So here is a diagram of a smaller circle, a larger circle. So if everyone will look up here. The question is, how many common tangents are there? And draw them. So it's asked how many are there and then draw them, but you kind of have to draw them to know how many there are. But let's just make sure we understand common tangents. So here is a common tangent. It is a line that is passing through one point of this circle and one point of this circle. It's tangent to both. Excuse me for one moment. Okay, I apologize. So there's a common tangent. So now what I would like to ask you is how many of them are there altogether? I want you to take 1 minute and I want you to try and draw all of them and see if you can figure out how many there are. In 1 minute I'm going to ask you how many and you're going to need to tell me how many. So take a minute to do that. Use the straight edge of the compass to draw your lines.
What?
You got about 30 seconds to try and find as many common tangents as you can. You can always just get up and try and take a different one.
That's why.
All right. So here's what I would like you to do. Hold up the number of fingers to represent how many tangents you found, common tangents you found. Go ahead now, turn and look at your classmates.
There's at least
Okay. So put your hands down. So many of you said 4, and there are. There is, and it's actually hard for me to draw them using these tools, so bear with me for a moment. So mine will probably not be perfect. So there's 2 of them. But you already got a little bit of a clue during the last activity that there's going to be internal tangents, and this is where it gets a little hard to draw.
Why is
So that's an internal tangent. It's a bit tough, but it's close enough. So that's a common tangent that's passing through the interior of the diagram. It's called a common internal tangent because it passes through the segment that would connect the centers of these 2 circles. If I drew this line right here, it passes through the center, whereas these do not. Okay? And then there's another one going straight through this way. So there are a total of 4 common tangents. Anyone have any questions? Okay, so now what I would like you to do is I'm going to put 2 minutes on the clock. And I would like you to sketch this diagram using your compass. This time the 2 circles are touching at one point. So I know that's hard to draw, but just do the best you can and know intellectually they are touching at one point right there. And then I would like you to find as many tangents as you can. So we'll put 2 minutes on the clock. got 30 seconds to try and find as many common tangents as possible. All right, let's come back as a whole group and hold up the number of fingers to represent the number of common tangents you found for part B. Now look around at your classmates. Okay, put your hands down. So, hopefully you saw the same two that existed in the first diagram. So we've got a common tangent here. And again, remember, it's hard for me to draw it perfectly, so bear with me. We got one here, and I know it's not perfect. So there's two. Some of you said 2. Some of you said 3. Where's the third one? Jada, where's the third one? Yeah, it's passing right through the middle. There's a third tangent passing right through there, touching at one point. Where's the fourth one? There is no fourth one. Because I said that they're touching in one point. Okay. Any questions, concerns of any kind? Good. Checkpoint number 2. Is this checkpoint number 2 or number 1? Checkpoint number 1. How many, so change that to a 1. How many common tangents does that diagram have?
Do we have to draw that?
Wow.
You do not have to draw it if you don't want to. Yeah.
That's what I did when I was wrong.
Oh, I'm sorry, I didn't put a clock. Apologize. So take another minute. 1 second. All right, let's see what you came up with. How many common tangents are there? I've got students 6, 10, 11, and 19. Student number 6. Student number 10. Student number 11. Student number 19. There is one common tangent. Here's what your picture should have looked like. There was one common tangent on the outside of the two circles. Anyone have any concerns or issues with common tangents? Good, so we've done a good job of laying the foundation. Let's do the real work. And let's start using the theorems. This is just a repeat of what you've seen earlier. So we have the tangent theorem that says that a tangent will always be perpendicular to the radius of the circle, if it is a tangent. We can use that fact to solve a whole bunch of different types of problems, starting with this. You are going to have to sketch the diagrams. You don't have to use the compass for these. A sketch will be fine. But in this diagram, PT is a radius of circle P. Is ST tangent to circle P? So, we are going to somehow use the tangent theorem to try and prove that ST is a tangent. You're going to take 1 minute as a team talk, and see if you can come up with a path of logic that will allow us to prove that ST is a tangent. So go ahead. You got 1 minute. Come up with something.
Just use the Pythagorean theorem to see if the triangle is a right triangle, and if it is, then ST is a tangent. Because like ST is a right angle. To see if it's a right triangle, and if it is, ST will be the No, it's on the same Yeah, but we're trying to see if like the triangle is a right triangle. That would mean that ST is
All right? This time I won't put people on the spot. What'd you come up with? I'll let you volunteer. Start with Chris, Davis, and then Michaela. Chris, what'd you come up with? Okay. Davis?
By using the Pythagorean theorem, like he said.
What can we do with that?
By taking 35 and 12, if you squared them, you squared both of them, added them together, and then
Okay, well, gather your thoughts for a minute. We'll come back to you, Michaela.
Since it's a radius, couldn't we say that TP is perpendicular?
No, because I'm not asking if this is a radius. This is a radius, but we don't know if this is a tangent.
I know, but if
What if it actually slightly turned a little bit and passing through the circle over this way? Then it wouldn't be tangent. In other words, I'm asking, what if it was, maybe it's like that, and it's not a tangent. So the question is, how can we prove that it is? Okay? So they were on the right track. We just need to, what will using the Pythagorean theorem allow us to do? Let's keep it simple. Sebastian? Very good. So that's actually not the Pythagorean theorem. Does anyone know what it is?
Pythagorean theorem converse.
Yeah, that's the converse of the Pythagorean theorem. Very good. So if we use the converse of the Pythagorean theorem, that will tell us it's a right triangle. If it's a right triangle, that means that this is a right angle. If that's a right angle, then they're perpendicular. If they're perpendicular, then it's a tangent. That's the path of logic. Okay? So that's what we're going to do. Go. Oh, you guys are too fast? Okay. So 12 squared plus 35 squared, does that equal 37 squared? Could someone tell us what the two sides come out to so I don't have to do all that work by myself? Shelby? 1,369? Is that right? I don't know, I don't remember. I'm hoping you're right. So this works out to be equal. So that proves by the converse of the Pythagorean theorem that this is a right triangle. So now we can add this to the diagram. Once we add that, we can say that ST is tangent, segment ST is tangent to circle P. So the answer is yes. And that's the evidence that supports it. Does anyone have any questions about that? Good. Let's elevate the complexity a little bit. Again, sketch the diagram. You've got a minute. Read the question, sketch the diagram. All right. So this is a bit tougher, but we're in geometry honors, so that's par for the course. So we're asked to find the radius. And you can see in the diagram, it's missing. But you can also see that this line here is forming a triangle. We're also told this time that point B is a point of tangency. So that point, if it's a point of tangency, that means that this line is a tangent, which tells us that this is what type of triangle? Kayla? That's a right triangle. So we could add this little detail right here to say that that's a right triangle. So what could we now use now that we know that that's a right triangle? What are we allowed to use because of that? Brandon? I don't want to, never mind.
Okay, since it's a right triangle, we can use the Pythagorean.
Yeah, we can now use the Pythagorean theorem. But it's a bit more challenging this time because we've got this bizarre distance here. But that doesn't change anything. So let's go ahead and set it up. This is A, this is B, that whole thing is C. So A squared plus B squared will equal C squared. Well, what's C? It's R plus 50 squared. Today's warm-up was very deliberate. I intentionally picked a question that forced you to reach back into your knowledge from algebra and try and bring it back because we're going to do it again. So we've got to simplify to try and solve. We've got r squared. That you can do mentally is 6,400 squared. 6,400 equals, but here's where you got to reach back. Go ahead, Catalina.
Can't you just divide both, like do the square root of both sides?
You can't because square roots do not work like division. So like doing that is not the same thing as doing the square root of one and the square root of other.
No, I mean, because they all have the square sign at the top, like the r squared.
Right, right.
So can't you just make the equations and everything is squared, just r plus 80 equals r plus 1?
No, you can't do that. Yeah, you can't do that at all. It seems like that would work, but it doesn't work at all. In fact, it doesn't work in lots and lots of cases. Okay, but now we need to simplify this. So how can we do that? Reaching back to algebra. It's all coming back to you now, right? Jabari?
You have to do, don't you have to do R
You could foil it. So you guys could come over, do a little side trip, and do r plus 50 times r plus 50 and foil it. But there's a shortcut. So remember, if you're interviewing for a job, and one of the requirements of the job is a skill like this, and the person sitting next to you has to foil it, but you know the shortcut, who's more qualified for the job? The one who knows the shortcut. Thank you, Brandon. So Alicia, what's the shortcut?
I think that you just, okay, I'll just have a way to change it. Wouldn't it be r squared plus 2,500?
Unfortunately, it's not that simple. It's not that simple. Right?
It'd be r squared plus 2 times r times 50 and then 50 squared.
That's right. Square the first term, square the second term, then multiply them together and multiply by 2. Either way, whether you do this or do the shortcut, you're going to get the same result. Square the first term, square the last term, like Alicia said, it's 2,500, but now multiply the two terms together and multiply by 2, and you get 100r. Now this looks nasty, but once you think about it for a moment, it actually works out ridiculously nice. There's an r square on the left and the right. They're just going to cancel each other out. It's 100r plus 2,500 equals 6,400. It's a simple two-step equation. Subtract 2,500 from both sides. That disappears, and we get, I'm sorry, I'm totally blanking, what? 3,900 equals 100r. R equals 39.
Wait, so you square the first term, then the second, and then in the middle, what do? Like you add them, or I forgot what you said.
Multiply these together and multiply by 2.
Oh, okay.
So it's basically double this times this. Or just foil it, like Zabari said. Okay? So we get the radius of 39. Any questions on how we did that? It was pretty high level. But the geometry you guys got. So it was just the algebra coming back that was a little bit challenging. Okay? Now, the tangent segments theorem. If two tangents have a common external point, then the two tangents are congruent. So again, we can say that that is congruent to that, if these are both tangent to the same circle. And we can use that to solve some problems. So example 3c, HK, segment HK and segment HG are both tangent to circle F. Find HG. Any thoughts on what we can do? Just one thought? 2 thoughts? 3 thoughts? Shelby, what do you think? Okay. That was a great explanation, absolutely. Because of the tangent segments theorem, and we're told that these two segments are tangent to the same circle, and they share a common endpoint, then they're congruent to each other. So we can say that 2a plus 4 is equal to 5a minus 32. Find the value of a, find the distance hg. Actually, this should not have a line over it. Sorry about that. My fault. That should not be there. So, I mean, for you guys, solving this type of equation should be almost mental math at this point. What does A come out to? Dalton, what does it come out to?
9.
Comes out to 9. Plug the 9 in right here. And what is HG? What does HG come out to? Am I going too fast or too slow? What's going on? Okay, Dalton, go ahead, finish that. Comes out to 22.
A is 12.
A is 12?
Yeah.
Okay, so why
Divided by 3.
so that's what I get for trusting Dalton.
Yeah.
Dalton, what did you do?
All right, so someone's got to correct me if I made a mistake. I'm just kidding. It's not Dalton's mistake. It's my mistake. So A is 12. So that makes HG
28.
28. So I apologize. My mistake. Other than the simple mistake, that computational mistake that I made, anyone have any concerns or questions? So we saw 3 different applications of 2 theorems. We were able to use the converse of the Pythagorean theorem coupled with the tangent theorem. We were able to use the Pythagorean theorem again coupled with the tangent theorem. And then we were able to use the tangent segments theorem to set 2 segments congruent to each other and find the distance. Any questions? Checkpoint number 2, I think. I accidentally put 3. This is 2. So find me the value of r, the radius of circle Q. One second. No worries.
Yeah, those are 2 digits. Not 3.
This times this has 2. No. It's part of the process.
It is easy to know r squared is whole r squared tangent r
Oh.
That's because it's a tangent. ST. trying to prove something is a red line, then you.
I hope you get the. I hope you get the walk over there here right
I said sorry.
And now you're mad at me.
It was on purpose.
Now you're mad at me.
I'm disappointed.
What? For what?
now.
You're making me unsure.
For what?
When you heard.
Accept my apology.
It wasn't.
Forgive and forget.
I just did. I was asking a good question. You never answered it.
Raise your die.
I didn't want to write it. You really need to go check. They're like,
All right, let's see how we did. All right, I got students 21, 13, 18, and 12. Student 21, what'd you get? Student 13. Student 18.
7.
Student 12. Everybody got the same answer?
Yes.
Answer is 7. Give me a thumbs up if you were able to get that right. Wow, very nice, very impressive. Anyone have any questions or concerns? Any questions on anything we've done? Draw a line across your paper. Your homework is on page 645, numbers 3 through 26, 35, 36, 37, 38. I put it in bold because it requires extra attention. Make sure you spend a little bit of time on number 38. It is supposed to be a slightly more challenging question, but it also requires ideas from the past incorporated with new ideas. It's the most critical question. Do not skip it. Do not pretend to do it. Don't ask your friend for the answer. Do it and work your way through it. Then either do the at-home tutor or read the next section or both. Your EOC is May 4th and May 5th. That's a little over a month from now. And you will have a quiz on 10.1 to 10.4 next week.